Hello, this is for the CD lab exam and I will be executing question number 8. The question is check for a valid relational expression and evaluate the expression. So for this question, we require two programs. One is the LEX program, which will be our lexical analyzer. And the second one is our YAC program, which will be our parser. So in this case, we simply take the input from the user. Input will be an expression. And we use our parser to parse it. And we provide the output, right? Which is the answer of the expression. Or if there's an error, we tell the error also. So for this, so I will open the YAC program first. I will show you the YAC program. So the YAC program, so this part is the definitions part where we have included all our header files, which we'll be using in this program, which is stdio and stdlib, right? So this part is the part where we declare our tokens. So we use two tokens for this grammar. One is ID, which is nothing but the identifier, right? It basically a variable name. And the second one is num, which can be a number, right? And the number is, it can be 1, 2, 3, something like that, right? A proper number, right? And this part between the two percentage symbols is where we declare our grammar rules. So this is our initial symbol, start symbol. And so when you write it on a piece of paper, you usually use the arrow symbol, but in YAC, we use this colon to signify what are its productions. So the statement gives an expression. So when this expression is found, we simply print that a valid relation is found. A valid relational expression is found, right? And then this expression will can give us other productions, right? Such as this production the where there's a left parenthesis and in between that there's an expression and then there's a right parenthesis. This includes all the cases where our relation expressions are parenthesized, right? If that is the case, then if that case is also considered. Similarly, we have other cases too where only the left parenthesis is defined and the right parenthesis is not defined. So since this is an error, we simply print that there's a syntax error, and the syntax error is that the parenthesis is missing. Similarly, let us talk about expressions which are valid, like this expression. So on left hand side, there's one expression. Right hand side again, there's an expression, and in between the two expressions, there is a lesser than symbol. So this is a valid expression for which we can find an answer. So we print lesser than relation recognized because this is a lesser than symbol, and then we also perform this to evaluate the expression. So dollar dollar is the semantic value of our parent, which is the expression, right? And then dollar one is the semantic value of our first child, which is this expression here, and dollar three is the semantic value of this child, which is our which is the third child here, right? We don't use dollar two here because this dollar two it refers to this child, and since we don't use it anywhere, we don't write dollar two. We just write dollar dollar is equal to dollar one lesser than dollar three, right? So dollar dollar will store the answer, and we simply print dollar dollar, right? Printing the answer basically. Similarly, we could consider a case where expression and the operator is present, but the right hand operand is missing. So in that case, we print that the right hand operand is missing, and then we simply call exit function to get out of the program. Similarly, let us consider the case where a greater than relation is used. So expression greater than expression on right hand side again, and we simply print that the expression greater than expression relation is recognized, and we also evaluate it, but this time we just replace the lesser than with greater than because this expression has a greater than symbol, right? So dollar dollar stores our answer, and then we print the dollar dollar on the output screen. Similarly, let's take the condition where the right hand operand is missing for greater than symbol. We print the message accordingly and we exit out of the function. So let us also consider the case where greater than equal to lesser than equal to symbol is used, right? And if expression greater than lesser than equal to expression, so this is a valid expression, so we print lesser than equal to relation recognized, and dollar dollar is equal to dollar one lesser than equal to dollar four. So we use dollar four here because dollar four refers to this expression, right? This will be dollar two and this will be dollar three, right? Because this has four children, this parent has four children in this case. So similarly, we can consider the same expression, this time with the right hand operator missing. we print the appropriate statement and we exit out. Let us consider less greater than equal to, right? And as you can see, we just replace greater than equal to with less than equal to symbol with greater than equal to, because this talks about greater than equal to, right? And then again, greater than equal to without the right hand operand, we print the right hand operand missing error. And then we also consider equal to relation recognized, dollar dollar equal to dollar one equal to dollar four, just like before, and we print the result. And then equal to expression without the right hand operand, we print the error and exit 0. And similarly with not equal to expression recognized, dollar dollar equal to dollar one not equal to dollar four, and printf, yeah, expression not equal to with the right hand operand missing, the printf statement is executed and we exit out of the program, right? It just prints that the operand right hand operand is missing. Similarly, expression can get it our id, similarly an identifier basically, which is like a variable name, can also be reduced to an expression. So these are the variable names that we use in C, right? Similarly, a normal number can also be reduced to an expression. Number is nothing but your 1, 2, 3, the constant value, right? So this is where we have declared our grammar rules. It all is our grammar rules, and then we have a main function here. We ask for the we ask the user for a relation expression. So after we get the relation expression from the user, we call the parse function to parse the input, right? So this simply calls the yylex function that takes in each unit of the expression and gives out the token, and then tries to reduce the whole expression to the start symbol, right? If it goes properly, we get the if it happens properly, then we get any one of these statements. Otherwise, if there's an error anywhere, then we get uh, so which is why the error function is defined. It goes into the error function if there is any error during the parsing, and we get invalid relation expression and we exit out of the function, right? So this is the Yak program. uh, then let us talk about the lex program. So this is the lex program. So this is where we define, when we make up definitions. So we have included y.tap.h, which consists of all the valid tokens of the Yak program, right? And this is stdio.h, and then we have this global variable called yyLval, which will contain the lexeme value of the token when it's matched, right? And similarly, we have another int val, which we'll be using in during the actions, where we define the actions for rules. So this is where we define our pattern, which is a regular expression, and also the actions associated with each pattern. So the first pattern is for a variable, an identifier in a C program. So it follows the rules of an identifier of a C program, which is that it can start with an alphabet. It cannot start with a number. It can start with an alphabet, and the subsequent characters after the first character can be a number or an alphabet or an underscore. So that is the convention that is being followed here. So as you can see, the first character will always be an alphabet. It will be uppercase or lowercase, but the subsequent ones will either be an alphabet, upper or lower, or it could be a number between 0 to 9, or it could be an underscore. And the star symbol indicates 0 or more occurrences of that, right? So if this is found, if this pattern is matched, then we print enter value of variable, and text is the variable that holds this lexeme value, right? And it's printed when we're displaying this printf. And then we do a scanf to get the value from the user. We store it in valve, and then we assign yyLval to val, because in the Yak program, when we need the actual lexeme value, semantic value basically, for doing the expression, for evaluating the expression, we'll be retrieving it from yyLval, and then we return id, which is the token. Similarly, the next pattern is for a number. So a number can be a normal number, or it could be a floating point number. So we have covered both here. So a number will obviously start from 0 to 9, right? One or more occurrences of 0 to 9, which is indicated by this plus symbol. And then if it's a floating value, then we also have this dot here, and also a question mark that indicates that it's optional. So it could either appear or not appear. And and after that subsequently we could have zero or more occurrences of of a number from 0 to 9. And if such a pattern is matched, then we take it then the then we take the value from yy text. The yy text will have a string value, and we use that toy function to convert it to int, and then we return the token which is num. Similarly, if there's a space, we just skip it, right? There's a new line, we return 0, and if there is a dot which indicates any character, we just return yy text of 0, which is the first character. So that is the end of our rules and the associated actions of each, so the patterns and the associated actions of each pattern. Similarly, we also have a yy wrap function just if the input is exhausted, right? So let me compile and show you the execution. So yeah, so we compile the flex program first, right? And then we compile the yak program, right? We have some warnings, but that's all right. And then we build both the lexical analyzer and the parser, right? And now there are some warnings, but we have no errors. Now we just execute it, right? So enter a relation expression. So I'll enter a normal relation expression, one greater than two, sorry, one less than two. And yes, so clearly our less than relation is recognized. That is what is printed here. And also it's the expression is evaluated here, if you can see. One is lesser than two, so this is true. So one indicates true here. And obviously, since we have reduced it to the start symbol, the valid relation expression statement is printed. Similarly, let me try three, sorry, three uh, greater than 4, and greater than relation is recognized, and it's evaluated too. Since this statement is false, since the statement is false, 0 is printed. But then again, since this is a valid relation expression, that is, we could reduce it to the start symbol, the statement is printed. Let me try with a variable now. Right, so I give a greater than, let me give 3, and for b, let me give 4, and greater than relation recognized. And since it evaluates to false, 0 is printed. And since we were able to recognize it, we were able to reduce reduce the expression to the start symbol. This statement got printed. Let me try an error thing. So one, right. So you can see your right hand operand is missing. We can similarly incorporate left hand operand missing too. We just have to, not include, just remove the expression on the left hand side and keep the keep expression on the right hand side. Right, just the opposite of what we defined for right operand missing. Right. So this is the execution of the program. Thank you.